Renewable energy operators today manage large portfolios of solar and wind assets. The challenge isn't capturing performance numbers, it's understanding what's really happening, identifying where attention is needed, and explaining performance gaps clearly to the non technical teams. This demo shows how we use AI assisted app design and Copilot intelligence to turn those performance requirements into a working solution quickly. Instead of designing everything from scratch, we use Planner and AI Designer. Planner captures what we want the app to do, and AI Designer helps us to generate the structure, screens, and logic from those requirements. We begin in Planner by clearly stating the demo objective and we press Generate. So the planner is generating the whole plan and designing it. As we can see, business problem, purpose of this problem, user requirements, everything is coming up. The planner has generated the user requirement and is asking if it is okay. Yeah, it looks good. So now it's again generating the other things which is needed. Now, the core of the model is the user processes that has been generated. You can see portfolio, performance overview and prioritization, asset performance analysis, AI-driven deviation interpretation and guidance. Different processes are being created. This also looks good. Next is the data model, which is being generated for this whole thing. That also looks good. Renewable asset, performance summary and operating context. And the technology behind the implementation, the whole thing. The Canvas app, the agents, the automations, which all things are we going to use here. This also looks good. So everything is getting stored at the backend, which is the Dataverse tables. So the whole schema is getting generated with a click of a button with the clear input of the business requirements. So good, everything has been created, as we can see here. So as we can see, the user requirements cater to the portfolio manager who is responsible for overseeing the renewable asset portfolio and ensuring targets are met. Also for the operation analyst who investigates the performance summary, asset trends and the operation context. And the Copilot advisor that provides the narrative reasoning for output deviations based on the context given. And the different processes here are the portfolio performance overview and prioritization, which enables the managers to gain immediate clarity on the overall performance of the renewable asset portfolio. It includes viewing total expected versus the actual generation, also filtration using asset type, site, and reviewing key KPIs also. Next is the asset performance analysis and the context investigation process, which supports the operations analysis in investigating asset level performance and compares expected versus actual output, ranking assets by deviation, severity, etc. And the third process is the AI-driven deviation interpretation and guidance, where the agent helps us to assess the asset deviations using narrative reasoning. It explains the plausible operational causes, distinguishes between explainable and concerning deviations, and suggests relevant follow-up actions as well. In this designer, we can also see the data model which has been created. As we can see, it is getting generated here, and the relationship which has been established between the tables can also be seen here. We can also modify these relationships or include more tables as and when required. But at this point of time, we will go with the current design. We'll go back. We can also have a look. See, we are using the Canvas app and the Deviation region Copilot agent for agent creation. We can also see the process flow diagrams here. We can wait for it to generate. See, the overview is shown here, which describes the business problem or the goal of this particular project and the user roles and the different processes involved here. And the data model, everything all together in one place can be seen here. And we can modify this as and when required. We can add things, we can delete things, and then create the components accordingly. We can also view the process in detail by clicking the different processes where the whole flow is displayed or getting explained. So let us have a look at the different components, the console and the deviation agent. First, we have a look at the Renewable Performance Planner console. As we can see here, we have the welcome screen with renewable assets, performance summaries, and the operating context. See, the renewable assets, the different solar farms and the wind parks, and the details are mentioned here. The region, the site region, the capacity of the solar farm, of the wind park, and the asset type, all mentioned here, which can be seen at the click of a button. Next is the performance summary for each of the assets, which gives the actual generation versus the deviation percentage and the expected generation. So all the details can be seen at the click of a button, and a new entry, a new performance summary can also be entered here. Operating context, which tells us the conditions or the weather conditions which could have affected the output of the different assets. Say, for example, in a wind park, it's a cloudy weather. Yes, so there is no wind, so naturally the output would have been low. There's a planned downtime. Say, for example, the solar farm, the condition was normal, so there was no constraint. Again, for cloudy, there was a planned downtime. In a solar farm, when there is a cloudy, it could be a planned downtime depending on the weather. So all these details are all linked with the Copilot summaries, which is automatically stored in the table with different flows. So all are interlinked. Next, let us have a look at the deviation reasoning Copilot, which explains asset generation deviations using operational context, offering clear narrative guidance and follow-up suggestions for managers and the analyst. We can see the different instructions given here and the knowledge source, which is the underlying dataverse tables. So let us test this agent. I would like to know which solar assets have deviations. Let us see what is it going to, what is the output for this. Yeah, solar farm E, A and C have the deviations. We can ask How much deviations? What's the expected output? And what is the actual output? Let us see. Let the agent take its time to fetch us the details. C. So for solar farm A, deviation is minus 9.52 percentage, where the expected output is 42, but the actual output is 38. Similarly, for the other assets also, it's given. So these deviations indicate that they have produced less energy than expected, right? We can also ask for suggest or recommendations for the improvement. Let us see what it is going to give us. Yeah. So many steps. It has given a detailed information. Here are recommendation for improving the performance of the solar assets. Review weather and environmental data, inspect equipment and maintenance records, analyze performance data trends. These are some of the methods for improving the performance of these assets. So we can see how this Copilot is so useful for the renewable energy evaluation. Thank you.